Hello, I'm Colin, and welcome back to my video series, Death to MC Lag. In video 1, we built our MC Lag lab. In video 2, I spent some time talking about the EVPN control plane, and in this video, we're going to configure as much EVPN-VXLAN as we can without breaking the existing MC Lag configuration. I actually had never tried this before. Every time I've done a cutover of a pair of devices in an MC Lag pair, it's just been a forklift. But I did get curious about how far I could get that configuration of EVPN-VXLAN before I had to stop and then save the rest for a maintenance window. So this could be viewed as a sort of transition strategy. If you wanted to get as much of this config staged and done as possible ahead of time, make sure your EVPN control plane is working properly, your peers are up. This could be a viable option. Like everything you see on this channel or anywhere else, I always recommend testing. This is why I like doing lab series like this. This was a fun one. It's pretty cool how much we can get configured before we actually are going to have to tip things over. In the next video where we actually do tip things over, i.e. the maintenance window part of the configuration, there's very little left. So let's get started. We want to first verify that MC Lag is actually working. I know it is because I checked ahead of time. Just to show you, I'm going to ping between client 1 and client 3 in the lab. You can also use show commands like show ICCP if you want to verify that it's working. It's working. Oh, I've got an artifact here. This is actually the first thing we need to do is add this link, but I'll delete it just so that we have continuity. Scroll this up. The first thing we need to do is add in the link that I just deleted. The reason for that is that we need a link that we can do our BGP peering over. The BGP peering we're going to be doing is for both the underlay and the overlay. I don't remember if I talked about these terms in the first video. I don't think I would have had cause to. And I'm almost certain I didn't talk about them in the second video, which dealt specifically with the EVPN control plane and not necessarily the concepts in an EVPN-VXLAN configuration that's on a switch. The term underlay usually is only ever used in the same breath as overlay. Whenever you're doing a configuration that you might consider standard or legacy, where you're just configuring straight L2, L3, spanning tree, stuff like that, you're working in what we would call the underlay, the global L2, the global L3 tables. This is the global routing instance, the default routing instance is the underlay. The overlay sits on top of the underlay, as you might expect, because of the term under over, and carries specific information for the protocols and interfaces that are associated with it. We have a underlay control plane. This is going to be BGP that is doing peering to ensure that we have loopback reachability between the two switches that are in our lab. And then the overlay will be the EVPN peering between those loopbacks that EVPN signaling is then pushed over, the route types and what have you. So the first thing we need to do is create that link. We don't want to reuse the ICL/ICCP link that MC Lag uses, because when we decom that, we don't want to have to try to separate those configuration elements. So we'll keep them separate. We'll just use the next link that is available, XE001. Slide these together because I like it when the lab is nice and clean. And we'll configure our interface and we'll configure our loopback. Honestly, we should have done that in the first video. The loopback, it should be configured on any switch you deploy. It is a unique identifier for that switch. It is the gateway to the control plane. It's where you would put your input filters if you were doing any type of hardening. And it's also, unless you specify and config otherwise, the source of control plane traffic. Not required for MC Lag, absolutely necessary for EVPN. Okay, let's just do stack interfaces, XE001.0 family INET address 172.30.0. I always use a 172.30 as my transit nets. /30. I could do a P2P here and use a /31, but I'm lousy with address space, so I'm not doing that. Interfaces, hello, 0.0 family INET address 172. I always use .31 for loopbacks, and I can leave the CIDR off because if you ever do that with a prefix in Junos, it'll just assume it's a host route and add the /32 to the end. And of course, loopbacks can only ever be /32s. All right, so loopbacks are up. The next thing I'm going to do is define my policy statements. You can do the rest of this in any order you want. However, if I configure my BGP and I put in import-export policies that I haven't already created and I run show commands, do also complain. I can always put them in afterwards, but this is just the sequence I'm going in. Edit policy options, policy statement. We'll start with underlay import. We actually won't have any import-export policies in the overlay, not for this exercise anyway. We'll just allow whatever we're advertising. But for the underlay, we want to make sure that we are limiting the advertised prefixes and received prefixes to just loopbacks, which is why it's so important to know the prefix space that I put my loopbacks in, because that's how we're going to design the filter. Ultimately, the underlay import-export policies are going to be identical. So I'll just create the import policy first and I'll copy it and give it a different name. Set term loopback from, we'll do a route filter. There's a couple different ways you can do this. I'm just going to use a route filter 0/24 or longer, which will give me /24 all the way up to /32 as a match condition. Set term loopback, then accept, and then we'll do a set term default policy, then reject. Great. Up, copy policy statement, underlay import to policy statement, underlay -export. Like I said, identical. We also need to create an equal cost multipath policy that will be applied to our forwarding table. Multipath requires this policy to be in place if you want to use load balancing with your BGP. Set policy statement, I'll call it ECMP for equal cost multipath policy. If you don't have a match statement, a from statement here, it matches all traffic. So my simple match statement is match everything by excluding a from match. Then load balance per packet, and then accept. Great. Up one, that policy goes into our routing options, set forwarding table, export ECMP policy. And while we're here in the routing options, we also want to set our router ID. Router IDs are, if you watched the last video, you'll know, but they are a tool that is used to uniquely identify the source of an advertised prefix in the context of EVPN. It is a unique identifier. Make it match the loopback, unless you have a very compelling reason not to make your life easier. Set router ID 172.31.0.1 for the left and 2 for the right. If you've ever dealt with peering before, you might have noticed that I didn't put in an autonomous system number. I could do that. I'm actually going to put it into the BGP configuration itself. That is up to you if you want to do it that way. I can't remember. This is a long time ago. I had an issue where I had underlay configs and overlay configs and autonomous system number that was defined under routing options, and the tiebreak didn't quite, it is deterministic and it is documented. I don't remember what the problem was, but I do know that if I just define my local and remote ASNs within the BGP configuration, that everything's copacetic. So I'm going to do that instead. Let's get started on BGP. And we'll do the underlay, and then we'll do a commit, make sure everything's still working, and make sure our peers are up, and then we'll do the overlay config after that. Edit protocols, BGP group, this underlay. All right, so it's external. We're doing interface peering. We'll set our import and export policies. Underlay import, set export. Obviously, I could have just created a single policy. I don't like to do that because even though this is super simplistic, it's a good habit to be in to have discrete import-export policies. So if you do have something in production you need to make a change to, you're just modifying the policy. You're actually not modifying the policy within BGP. We're going to be doing family INET unicast for the loopback advertising. We'll set our local AS 6501 on the left, 2 on the right. They do have to be different since this is eBGP. set multipath. This will allow us to make use of the equal cost multipath policy that we just put in place. We'll set up BFD, bidirectional forwarding detection. This is fast failover, liveness detection. I believe the default minimum interval is 300. We're going to give it discrete configuration anyway. Again, I like to see what the faults are whenever possible in config. And we've done just about everything we need to. So now we'll just set a neighbor statement. If I can spell 30.0.2.1 with a remote, peer, sorry, peer yes here, 65.0.0.2 on that side, 1 on that side. That neighbor statement is going to inherit all this other stuff, which makes my life easier if I had to add multiple peers, which I don't in this case. So all I have to do down here is just add the unique peer ASs, which makes sense because it's eBGP. You'll see that for the overlay configuration we're about to do in a second, I won't even have to do that. I'll just have to do a neighbor statement. So let's do a commit and quit. We'll make sure the peer comes up and we'll make sure that our clients can still reach each other. It's going to take a second. So while I'm waiting on that, we'll make sure this is working. Looks good. Wait for this to establish. There it goes. MC lag still working. Great. So our underlay is configured. Policies are configured. MC lag isn't broken. That's good. But we also haven't done anything special yet. So the next bit is the EVPN. Oh, we can also do this. Just make sure that our loopback is advertising correctly. BGP, let's do 30.0.21. Enter. There we go. Great. Figure edit protocols. BGP group overlay. This bit of configuration is even easier than the other one. Set type internal. We do want to set a local address of the local loopback. That is very important for VXLAN to work properly. Set local address 172.31.0.1 on this side, 2 on that side. Set local AS. Since it is iBGP, it's going to be the same on both sides. Set multipath again. Set family EVPN signaling. And then we'll set our neighbor. Two on that side, 1 on that side. Enter. Top, commit and quit. This will get our EVPN peering up. We're not really going to be advertising anything yet, but the control plane is now active. If we do a show route, we're not actually going to see any new route tables either because we haven't advertised anything into BGP. The next bit of configuration is going to be encapsulation type for EVPN. We're going to start getting into VNIs, and most importantly, we're going to start defining some of the VXLAN and VRF elements. After we do that, we are going to see a VXLAN route table, but we'll also have gotten as far as we can get. So we're almost there. Back in, edit protocols. It's time to go to EVPN. Set encapsulation, VXLAN, and set extended VNI dash list. We can be very prescriptive so that we're only advertising using specific VNIs. For the sake of what we're doing today, I'm just going to say all. And that's all we need for EVPN. We need to switch options. If we do a show command here, we're going to see the service ID for MC lag. I talked about this in the first video, so we're not going to get into it here. We are going to add a VXLAN tunnel endpoint source interface. So set VTAP source interface. This is loopback 0.0. This is, again, like the peering and having your source interface and having loopback configured is required. We're also going to set a route distinguisher. The route distinguisher is kind of like a router ID. It associates a route with a specific router and a routing instance. In this case, that routing instance is the default routing instance. If we have a VRF defined, there would be a route distinguisher for that VRF as well. Think about it like this. A EVPN route type is received at a router. It's going to have information. Let's say it's a type 2 route. It's going to have information about a host, MAC and IP address. It's going to have a router ID from the originating router, and then it's going to have a route distinguisher, which is going to tell that local device, that the host is reachable on the other device. It finds that out by router ID, but then what routing instances it go into is where the route distinguisher comes into play. So it is just a bunch of breadcrumbs that lead back to where that host is actually plugged in. I'm going to use the loopback interface address 172.31.0. And then we'll do a 1 on this side and a 2 on that side. And then the syntax here is a colon and a 1. Kind of has a community sort of feel to it. I'll hit enter. The last thing that we can do is the last command without breaking MC lag is the VRF target. So set VRF dash target. This always starts with the word target. I'll do 1, 1. The VRF target is a community. And when you define this community, it determines which routes are advertised and which communities are attached for this default routing instance. If we were to configure a VRF and assign interfaces to it in configuration, it would have a unique VRF target as well. And this community is applied and used as part of a hidden import-export policy to ensure that, particularly in a multi-tenancy situation, routes are being installed in the correct route tables. Enter, top, commit, and quit. So, biggest question, still working? Yes, indeed. And what do we got on this side? Show route. We should see a VXLAN table. We do. It includes our local interfaces. Not much else, and that is actually the point. There are 2 more things that need to get done before EVPN's working, and it would be done in conjunction with cleaning up the MC lag configuration. That is for the next video. For now, we've got the EVPN control plane in place, a bit of the VXLAN configuration done, and everything's still working. So the next video will really be that cutover. As always, thank you for watching through. The next one hopefully will be shorter than this one because we don't really have a lot left to do for this cutover. I hope this has been informative. As always, if you have any questions, please put them in the comments. I will get to them as quickly as I can. Thank you again for watching. I do love making these videos, and hopefully they're helping you learn about campus fabrics. Have a great rest of your day. Take care.